Hello, welcome back. This is Module 5, Video 6. In this video we're going to build out our exercise model, which is kind of the crux of the application. Okay, so we've already got our exercise class stubbed out as created in one of the previous videos. What we don't have is a unit test fixture, so let's create that. Okay, so what is an exercise? What does it have? The obvious thing is it needs a name. And recall that this is just going to be entirely immutable, this class. It's the only mutability we have in our model layer is in the execution context, which we did in the last video. And we're also going to need the number of sets and the number of reps. Now I could call this sets, but that's kind of suggestive of there being a collection of sets. So I'm going to call it set count. And same thing for repetitions. And the only other property I think we need on exercise is the duration, so we know, so we can give the user some feedback of how much they've progressed through the exercise. And the only method I think we need is some way of executing that exercise, or the only public method anyway. Okay, so I think that suffices for a public API. Let's start writing some tests around this. Okay, so here's the test that I've just added. The constructor throws if name is null, or if the set or rep count is less than 0. Make sure that our name property returns the name, same with set count and rep count. Now that implies that I've needed this constructor here in our exercise model, and it also implies that I've needed to update this execution context fixture, because remember we created an exercise in that fixture. Now we need to pass in the name and set count and rep count. So let's make sure they fail. Okay, good, they're all failing. Now let's work on the implementation here. It will be straightforward. Okay, I need to add a reference to my helper Trinity library, just so I can do this argument validation here. There we go. All I'm doing, of course, is checking the arguments to the constructor, assigning them, and then returning them from the properties. That should enable our test to pass. Cool, they do. So let's move on to the real meat of this class, which is, well, let's do duration first. Let's write a couple of tests around that. Okay, so you see I've written a test here to make sure that the time span is 0 the duration is 0 if there are no actions. But currently we have no way of defining what actions need to execute as part of that exercise. And this next test requires me to come up with something for that, because we need to make sure that the duration returns the sum of all the actions. So we need some way of mapping events in the exercise to actions to execute. And I think what I'm going to do is just have another parameter to the constructor here, which is just an enumerable, and we need some way of saying when this matcher, given our event matcher abstraction, if that matches, then run this action. So we need something there to kind of hold that information. I'm just going to call it matcher with action, for lack of a better name. I'm not entirely happy with that, but and of course, because we're taking an enumerable of that, we want matches with actions. And this matcher with action thing is going to be really simple tuple type, or tuple as some people call it, even though it's only got one p, which always confused me. But it will just simply have the matcher, the event matcher, along with the action to execute if that event matcher matches. Right, so that's our simple matcher with action type. Not much to it at all, but what we can do with that now is we can capture a list of that inside our constructor here. Now remember, because this is immutable, we want to really be careful here. And the simplest way to make sure that this is an immutable list and not something that clients could get a hold of and mutate is to use the immutable list or the immutable collections NuGet package to create an immutable list. And I believe I'll need to add that as a package. Okay, and we need to add a couple more tests around this before we go any further. First of all, we want to make sure it's not null. Okay, so we're making sure it's not null, and I've also gone back and fixed up these other tests because, of course, the constructor has changed again. There will be another breaking test in the execution context fixture, but we'll get to that shortly. It's no big deal. See, I'm just passing in enumerable.empty most of the time. The only time we're actually going to need some actions here is in these, tests for the duration and tests for the execution of the actual exercise. So here, with our duration return 0 if there are no actions, all I've done is just passed in no matcher with actions. So there will never be any actions to execute because we're never going to match on anything. Whereas with this one, we need to actually pass in some matcher with action objects so that some actions are chosen for execution and therefore they influence the duration of the exercise. Now I could expose this as a property. It'd certainly make it easier to test. Well, it'd make it easy to test that what we pass into the constructor is exposed. But honestly, I don't think there'd be any need for it other than testing, so I'm not going to add that just for the purposes of testing. We can test it incidentally through these other public APIs, which is about what we're about to do with the duration, for example. So let's do that. So I've not actually created these mock objects yet for our model abstraction, so I'll do that now and fast forward through it because you know, we've seen and discussed all this, how this works in an earlier video. Okay, so what I've done here is I've created a few mock actions and given them a duration, and then I've created a few mock event matches, and then I've created this matches with actions list, and I've associated each match with its action. I'm passing that into the exercise, and then the idea is here we would expect each of these actions to be executed according to what its event matches says. Problem here is I'm going to need the events themselves in order to progress here, because the exercise, the way I see this working is the exercise will need to kind of loop over the events, such as, you know, the exercise is starting, the set is starting, the set is ended, etc. And then for each event, it will need to check which matches match. And if they do match, it knows that it needs to execute the associated action. Now, of course, it doesn't really make sense here to be kind of making up events just for the purposes of testing. So I think what's going to happen is we're going to have to flesh out the events, which is fine because they're not any behavior at all. They're just simple data objects that hold information about what's happening throughout the exercise. So I don't have a problem doing that, and certainly don't need to be tested, I don't think. But the problem is I can't really flesh this test out until I understand what events will be raised. I have a decent idea, but so what I've done here is I've just put a question mark here. So the idea is that we're going to try and set this up so that each event matcher matches more than once, but not every time. So then we can figure out, you know, what should the sum be of each action execution, and we'll stick that here, and we'll verify that it is running the correct actions per the setup we've got here. But anyways, let's switch to our exercise and have a think about, you know, what we need to do here in order to get the duration. And first of all, I think we only need to calculate this once because it's immutable. We know that this matches with actions thing isn't going to change. Although the matcher itself could return a different value each time it ran, that's not the intention here, so I'm not going to bother worrying about that scenario. The matcher is supposed to be functional in the sense that if you give it the same inputs, you'll get the same output. So we should only have to calculate the duration once, and we can do that in the constructor and then store that as a time span field and return it here. But how do we calculate it? What we need to know is what events will be raised by the exercise, and then for each event we need to know which matches match, and then for each matching matcher we get the associated action, and then for each action we get its duration and we sum that up. So let's start with the easiest piece of that puzzle, which is to get the events. I'm going to pass in the execution context here because we're going to need to tell the execution context where we're up to, so that matches have the information they need to know whether they match or not. So for example, when we're first starting here, we need to set the current exercise to this. And then we can return our first event, which would be before exercise event. Now remember that every event needs to take the execution context, but it can also take some extra information specific to that event, and I think this event will just take the exercise. So we'll have to define all these events shortly, but let's concentrate on one thing at a time here. So now we can loop over the sets in our exercise. And I'm going to use a 1-based index instead of 0-based, just because it probably makes more sense to users to talk about set 1 rather than set 0. Okay, that's the gist of what we're trying to do here. So we start off by assigning the exercise to the execution context, yielding this before exercise event, and then we loop through the set numbers, and then we pass the current set number onto the execution context again, yield a before set event, and then do similar thing for the reps. Pass it onto the execution context, but then we raise these 3 events in succession, before, during, and after the rep. And then once we've done all the reps, of course, that means we've finished the set, so we've got this after set. And once we've finished all the sets, that means we've finished the exercise, so we've got this after exercise event. And I did discuss all these events in the overview for this module. If you're a bit lost here about how these things tie together, I suggest you go back and watch the overview. But what we need now is to just define all these event classes. Okay, so it's as simple as that really, just taking in the bits of data that we need to expose and then exposing them. I am going to move this though into an events folder. Because we will have quite a few events and we may as well keep them nice and separate. So I see the root namespace here, the workout watch.models, that's kind of our core abstractions, and then the specific implementations of those abstractions will live in a separate namespace. Now the other thing that strikes me here is we're going to have very similar code in a lot of events, specifically this storing and checking of the execution context. So I think it makes sense just to have an abstract base class here called event or event base. So let me add that. Okay, there we go. So very simple, just move that execution context property into a base class. Since all events will have that, that'll just save us a bit of hassle here. And there's our before exercise event. So let me just go through the rest of these and create them. And actually, we're going to have a very similar situation with our set and rep events, in that we're going to have some common functionality here, which is to take and expose the number. So again, rather than repeating myself all the time, I'm just going to create a base class called numbered event, and they can all inherit from that. Okay, so now our before set event is as simple as this, and so too will our other events like after set, before rep, etc. Okay, and this last event, the after exercise event, I could also have abstracted out this functionality of storing and surfacing the exercise, but it hardly seems worth it for two classes. Maybe I'll do that later if we need to. So that's it for our events. I mean, they're all extremely simple, so I don't think I'm going to bother testing them or doing anything else with them other than tidying up the code, formatting. But now you can see we've not got any issues here with this code. All these types exist now. So now we can probably reason about this test. We know what events should be raised, so we know what events our event matches should receive as the exercise class kind of iterates through its events. So we can set up some expectations here for these event matches and then only return true in certain cases. And then based on that knowledge, we can figure out how many times those actions should execute, and therefore how long the total duration is of the exercise. Okay, so what we're saying here is when our event matcher gets called, we don't check the event here, we just let any event through, and then we do, in the return statement, we return based on the type of event. So here, for example, we're saying only if it's a before exercise event will this associated action execute. So that means action 1, which has been associated with event matcher 1, that will only execute when the before exercise event occurs. Action 2, on the other hand, will execute when the during rep event occurs, which happens for every rep, and action 3 for the after set event. So based on that, we know that action 1 should only execute once because there's only one before exercise event, so that's 10 seconds. Action 2 should execute for every rep. We've got 2 times 3, we've got 6 reps. So 6 times 3 is 18, so we're expecting 18 seconds of action 2. And action 3 is only after a set. We've got 2 sets, so that's an extra 2 seconds. So 18 plus 10, 28, plus 2 is 30. So we're expecting 30 seconds in duration here. Now we're still not going to be able to build, so just let me fix the issue with execution context fixture. Okay, now we can build, so let's make sure it fails. Okay, we've got a couple of failures here. We're not checking the matches with actions is null, and our duration calculation obviously isn't there yet, so let's fix this one first. Okay, so now we've got a way of determining all the events in the exercise. Now we need a way of getting the events along with the associated actions for that event. So something like IEnumerable of, and we don't actually have anything yet that stores an event with an action, or with a set of actions rather. So we'll define that as an inner class because it doesn't need to be public. In fact, it can just be a structure. Okay, so another very simple type that makes me wish C# had record types, but there it is, we're just storing events with the associated actions. So now what we want to do is figure out which actions to execute for the events, which means we probably want another helper method here to get the actions for a given event. So let's write that first. Okay. This is where we use our matches with associated actions. And we check whether that matcher matches the event. And if it does, then we return the action that has been associated with it. Okay, so now to get events with their actions, we can just get all the events and then create a new event with actions for that event, and then use our new get actions for event method like that. Okay, so just to be clear here, we're getting all the events that that are contained in our exercise using this code that we wrote before. And then for each event, we will create a new event with actions object, which is just this record type that we created. And in order to know what actions are associated with that event, we call our get actions for event here. And all that's doing is just looping through our matches with their associated actions, checking whether the matcher matches, and if it does, then we ensure that that action is included in the actions for that event. Okay, so that gives us a way of knowing what actions are relevant to the exercise, which means we can think about now how we turn that into a duration. So if we'd want something like, we'll create a field to hold this, which can be read-only. And we can now use our get events with actions. But we're going to need an execution context. We'll come back to that in a sec. But then we can do a select many to flatten out into our actions, and then just get the duration for each of those actions, and then aggregate those together like that. Now the execution context is interesting. We need one because otherwise the matches have no idea whether they actually match or not. But we don't need to keep it around, we just need kind of a dummy one that we use for the purposes of this calculation, and then we throw it away. So let's just create a dummy execution context like this. Xamarin, Xamarin, Xamarin. And pass it in here. Now that should get us at least some of the way towards the working duration. Let's see where we're at with our tests. Okay, we've still got failures here. So we've got a null reference problem somewhere. Exercise 108. Oh, we're not actually assigning this yet. Of course. Which, yeah, Xamarin Studio is actually trying to tell us there with the squiggly, but okay, yeah, we're trying to aggregate here when possibly there's nothing in the sequence, so we need to default if empty. Oh, we're getting close. We've got all but one, which is the main one we were testing. So now need to figure out what's going on there. And well, that's probably because we've not actually returned the duration from this property. Let's try that. Okay, excellent. So that's probably a large part of the battle here, because this execute async method is going to leverage a lot of this stuff as well, because it needs to loop over the events and loop over the actions to execute those actions. But let's start with the tests. Okay, so here's our test. I've used this other one as a starting point, and then all I've changed really is to say that instead of grabbing the duration, we are actually executing the exercise, and we're verifying that each action gets called, you know, the number of times we're expecting. So the first one is just once, the second one is 6 times, and the last one is 2 times before each set. So that's one test we can do. And let's use that as a starting point for our implementation. Let's make sure this builds and fails the test. Okay, that's failing. Actually, I just thought of another test we'd want, a very simple test, just to make sure that the execution context is not null. Okay, so let's make sure these tests fail. And they do. Except I'm not sure they're failing in the way I expect them to fail. Just a second. It's hard to read this because it's so big. Expected argument null was null ref at 97. Okay, of course, because we're just returning null here for the task. Okay, so let's make sure context is not null. And what do we want to do here? We're going to need to run asynchronously here. But essentially we want to take a similar approach here. We want to loop over all the actions for all the events. And then for each of those actions we want to execute them. So right, so looping over all the events with their associated actions, and then looping over those actions and executing the actions. So let's see where that gets us in terms of our test. One failure. Whoops. Okay, so we're going to mock that as execute async being called, of course, because our action mocks are being executed, but I've created them as strict mocks. We probably want to use mock behavior loose here, but we just need to make sure that our loose mock, yeah, I've already done this, so when it's loose, I've said that executing the action will just return true straight away. So let's try that again. Still failing. Member not called, so verification has failed. Okay, I've just had a look into this offline because I was a bit confused as to what was going on here. Turns out it looks like it might be a problem with PickleMock, in that the way this is supposed to work is if I just pass in a value, as I'm doing here, to this mocked call, it's supposed to interpret that exactly as if I had written it is that specific value. However, looks like that mustn't be working, because if I do it explicitly in this fashion, then the test passes. Let me just show you that. Okay, so so it's passing fine as long as I'm explicit about specifying it is. So that looks like a PickleMock bug, so I'll fix that offline and release a new version accordingly. But let's continue on in the meantime. So all our tests pass, but are we doing enough here? My gut feeling is that we're not, but we need to write some tests to prove that we're not. The obvious thing I think we're missing is support for skipping ahead. Remember we added this skip ahead property to our execution context, with the idea being that anything above 0 means we need to skip ahead in our exercise program to get to the starting point of wherever we left off, last time. So if we were to execute an exercise and pass in a skip ahead, we expect any actions within that skip ahead to just be skipped over without execution. So let's write a test to verify that behavior. Also, I don't think we need this here. I don't think we need to set up expectations for duration. So I'll remove them. So let's use this code as a starting point for our next test. Now in this case, well, let's wait till we get there, but I can see we're going to need duration already because that's how we're going to decide in the logic to whether to skip over an action or not is by its duration. But we'll get back to that. So you can see what I've done here is I've got 3 actions, 2 of which will throw if they're executed, and all of which will execute before exercise event on the before exercise event. And by the way, if we pass in more than 1 action to execute, they'll just be executed in the order defined by the matches. So because we're giving event matcher 1 first, its action would run before event matcher 2, etc. So on the assumption that, well, let's put it in now so that this test actually makes sense. When we get the duration for action 1, let's make that 10 seconds. So if we were to skip over 13 seconds of the exercise program, that should skip those first two actions, and we should only execute action 3. So to test that, we create our execution context with a skip ahead of 13 seconds, and we verify that action 3 was called exactly once. And of course, if either of these 2 actions are executed, then we'll get an exception. And our test will fail accordingly. Okay, let's try that. Make sure it's failing. Okay, it's failing, and it's a little hard to tell, but it's failing in the way we expect because we've asked it to throw without giving it an actual exception, so it's just throwing an invalid operation exception, which is the default behavior of PickleMock. Perhaps I will change that as well in PickleMock just to give a nicer exception message so it's more obvious what is going on. Right, so now let's look at the implementation. So essentially what we want to do here is check whether the context has some skip ahead outstanding in it. Now if it's greater than or equal to this action's duration, then we can just add the progress to the context and continue. Let's try that. Okay, so now we're getting a failure on this other test because we didn't set up any durations for the actions. So essentially what's happening is it's going to come in here and say, is the context skip ahead greater than or equal to the duration of the action? The duration of the action is 0, so it's just going to skip over all those actions. Is that the desired behavior? What if we had an action at the start of our exercise program that just happened to be a 0 length action, but we always want that to execute? For example, it's saying something. I don't think when we get to the point where we're writing the say action, I don't think it's going to have any duration because we can't tell how long it's going to take. So I think this is not the right behavior we want here. We want to make sure that this context skip ahead is greater than 0 and the action, and it's greater than or equal to the action's duration. But we probably need a test to kind of back up that behavior. So execute async does not skip 0 duration actions. Okay, there we go. So single action, no duration to it, so it's 0. And when we execute with no skip ahead, we still expect that action to be executed once. So that should fail. Yep, so 2 failures. Let's make sure that we've, yep, cool. Let's make sure, well, let's put in the correct implementation now. So if the context skip ahead is greater than 0, and it's greater than the action's duration, then we skip the action. And now we're passing. Excellent. But there's more we need to test here. For one thing, imagine the users coming back from, they've closed the application when they're halfway through an exercise program. They're coming back to the application. We want to show where they were up to last, which means we pass in the execution context with some skip ahead. And I think we'd start pause. We wouldn't kind of start the exercise program automatically when they open up the app again. That seems a bit weird. So we would start up pause, but we still want it to skip ahead to the point where they were at. Otherwise, the user interface would show them that they're right at the start of the exercise until they've hit play, which would be very confusing indeed. So we need to make sure that we skip ahead even if the context is paused. So that's going to be very similar to this test, I guess. So let's use that as a starting point. Yeah, so the test passes. Okay, so this test is much the same as this one above it, except that we pause the context prior to the execution. It's a little odd that we still expect our action 3 to execute because we're paused. You might expect it not to execute, but the fact is nothing is waiting for that to execution context to unpause because our actions are just mocks. They're not actually doing any waiting. We could try mocking the implementation of execute async for action 3 to actually wait for the context to unpause, but that doesn't actually gain us anything for this test except complexity, so I'm going to leave that out for now and move on. I think we just need some simpler tests now to make sure that execute async is updating the current exercise and current set, etc. So I will type these out and fast forward through them. Okay, so there's a few more tests here. Just making sure that the context is being updated with the current exercise, the current set, and the current repetition. And of course, I've done this wrong. This is an observable, so we need to convert that to a task. And await that task. I think from memory I put in default timeout here. Yes, so it defaults to 3 seconds. Remember, this is just test code, this particular helper. So it makes perfect sense for us to only wait, up to 3 seconds for that list to be populated. Right, so now I can await that task, and that will give me the actual sets like that. Same deal down here. Okay, and it's failed on both of those because I forgot something else, which is that it needs to know how long to wait for, like what it's waiting for, of course. So we're only expecting 3 sets, and whoops, why is that 2 tasks? That should be take 3 and 5 reps, like that. And now we're passing. Okay, cool. So I think that about covers it for our exercise model. I may add some logging in here just because I think it'll be useful to know, particularly when it's executing which, where is it? Here, which actions are being executed in response to which events. I just think that could be useful later on down the track debugging. So that implies, of course, taking our logger service as a constructor parameter here. So I won't do that as part of this video. This has gone on long enough, I think. But yeah, I'll do that in a separate commit, and you can check that out after the commit for this video. Awesome, so that's a wrap for this video. See you in the next one. Cheers.